Students, hello everybody. Today what we are going to learn, I haven't given you in the note. So whatever we are doing, you have to copy it. Okay. Today we are going to have some conceptual, concepts. Okay. See, let us just come to just the revision. See, in the last class, we had discussed something about the Biot-Stewart law. Biot-Stewart law is a means by which we can find out the magnetic field due to the elemental section, and how to find out the magnetic field? We can find out the magnetic field by this expression. That was the one we have learned, right? Now, what is the direction of the magnetic field? The direction of magnetic field is the cross product of dl and r. That is given from screw from dl to r. We need to rotate from dl to r, and in what direction it points? That is the direction of dB, right? Or right hand thumb rule. Thumb rule is also the one, right? Then one thing we need to understand, that to find the magnetic field, we need to use the Biot-Stewart law. That is the one, right? Then for a circular coil, we had derived that at the center, by the use of Biot-Stewart law, the magnetic field is given by mu 0, what it is? Mu 0 I by 2a. This we derived it by the use of Biot-Stewart law, right? Here also we had used the Biot-Stewart law at the elemental section, then we did for the whole wire, and that way we did it, right? Then we had generalized for any wire to find the magnetic field at the center. The expression is given by what? Mu 0 I by 2a theta by 2 pi. This much we have learned. Again, how to find out the magnetic field at a point? By the use of Biot-Stewart law. Biot-Stewart law is holding for the elemental length only. That we need to keep in your mind. Okay. Now today we are going to find out, okay, we'll write the heading magnetic field due to a finite wire current carrying wire, because current is important. Magnetic field due to a finite wire at say perpendicular distance, perpendicular distance. What distance shall I use? Perpendicular distance x. Okay, this is the heading. You can write it along with me. Now what does it mean? Say this is a wire, okay, finite wire. All right, now let us find the magnetic field at this point. All right, what name shall I call this? Point P. Okay, now what is the perpendicular distance of this wire? We took the distance at x. This wire must be carrying current in order to have the magnetic field, right or not? Right? Now how to find out the magnetic field at this point? Now to find the magnetic field, we need to use the Biot-Stewart law, right? But we know the Biot-Stewart law is holding for the elemental section, right? So what I am going to do, I am going to choose a very small elemental section. Let us call this section as dl. dl is a vector. What is the direction of dl? This is current direction, is the dl direction. Okay, fine. Let's say this dl, this is so small that this dl is at a distance of say r. It's r away. Now r is also a vector. What is the direction of r? Direction of r is along here. right? See, this thick arrow shows the direction of current, while this arrow shows the direction only. Okay, if it making you confused, no, right? Now what is the magnetic field due to dl? Biot-Savart law? Yes or no? Biot-Savart law. Okay, one more thing. Let us choose this elemental section is making an angle theta at the center. Okay, let it make angle theta at this point. All right. If this is theta, this is 90 degree, then what is the measure of this angle? This angle is what? It will be 90 minus theta. One thing we need to, only thing given is x, nothing else. These are all our assumptions. Okay. Now due to dl, magnetic field, let us find it out. What it is? Mu 0 by 4 pi, which is a number, 10 to the power minus 7. What is the current? I is the current. Okay. Then due to the elemental section, what it is? dl cross, what is the distance of dl from the point? This is r. dl cross r divided by r cube. This is the Biot-Savart law. Now what is the angle cross product is there? What is the angle between dl? This is, if I write it in this in terms of magnitude, then this is what? I dl r, what it is? Sine. What is the angle between dl and r? What is the angle between dl and r? Isn't it 90 minus theta? Not this theta, right? Then this will be what? Sorry, this is 90 minus theta. Excuse me, it's difficult for me to write. Then divided by what? This is r cube, right? R cube and r, it will become r square, right? Then how much is the magnetic field magnitude? Magnetic field magnitude is what? It is mu 0 by 4 pi I dl, r and r cancel out. Sine 90 minus theta is what? Sine cos of theta divided by what? R square. This is the magnetic field due to dl at P. I repeat again. Alright. Now, if you look at it, now we need to integrate. I have to take another length dl, another length dl, another length dl, another length dl, another length dl. That way only I can find out the magnetic field at this point, right? Okay. Now, if I take different elemental sections, what are the variables? See, if I take another elemental section dl, dl is a variable, right? Theta will also change, right? Fine or not? If I take this elemental section, theta is different, right? R is also change. So what here? dl, theta, r are what? All variable. See, in the integration method, there have to be only one variable, but here are what? There are 3 variables. Is there is any method to do this? Then yes, we will find out the way. Alright, say this till here. Let's say this length, this length is L. Say up to this length only I'm choosing it over here. Okay, say this length is L. Alright, then if this length is L, then do you know what is tan of theta? Okay, what okay, then what? Tan theta is equal to opposite by base. How much opposite we are taking? L by x. Is it okay? Subika, any problem? Thik chani? Okay. So this is the one. Now what is L becomes? L is equal to x tan of theta. Yes or no? Means what I am trying to do, I am only choosing one variable. Okay, dl is a variable, theta is a variable, r is a variable. Because as the elemental section changes, r value will change, theta value will change, even dl will change. It's a difficulty in terms of mathematics. Okay, now this is the one. Let us differentiate. Okay, if I differentiate, okay, if I differentiate it, okay, then what it will become? dl by d theta. What is the differentiation of tan theta? X is a constant, perpendicular distance, not going to change. Differentiation of tan theta is what, student? It is sec square theta. Am I clear this one? You have to learn from the, what to say. See, differentiation. D sine theta by d theta is equal to cos theta, right? Similarly, differentiation of tan theta by d theta is equal to sec square theta. I think you have seen there in the mathematics, so I'm not going to repeat it. Alright, then what this dl will become? dl will become what, student? X sec square theta d theta. Means what? I have converted this dl in terms of theta, which I was wanting it. Okay, another. Can I convert this r in terms of theta? Okay, yes, we can do it. See, conversion. All right, r is hypotenuse, x is the base, right? Then what? Cos theta is equal to, let us call this as equation number 1. All right, cos theta will be what? Base by hypotenuse, right? X by r. Am I making clear? Then this r is equal to what? X by cos theta, right? Then this, can I write it is x sec theta. See, I have converted this r also in terms of theta, correct? Okay, now substitute these values in equation number 1. All right, I'm going to do it here. I'm removing it. Okay, all right, so you are going to substitute it all here. You can pause it and you can write it. Okay, now if you do this, dB is equal to mu 0 4 pi I. dl was what? dl was what? dl was x sec square theta cos theta. Okay, sec square theta d theta it was, sorry, d theta should be here, right? And this is what? r is equal to what? X sec theta, right? X sec theta, so r square will be what? X square sec square theta, right or not? Yes. Now what are the things we can cancel out? This one cancel out, this one cancel out. So what is dB? dB is equal to what? Mu 0 4 pi, right? Mu 0 4 pi, what it is? Cos theta d theta by x. See, only one variable is involved, right? Then b will be what? b will be the integration of dB, and this will be, okay, I is there at the top, right? So it will be what? Mu 0 I by 4 pi x integration of cos theta d theta, and what is the integration of cos theta? It is sine theta, right? Okay, now when I am integrating, when I am doing this adding up, all right, what is the, how the variation, what are the limits involved? Okay, okay, sorry. Let's say this, it is, we are integrating from down to top. So this is the middle part we took. So let's say this angle is phi 1 and say this angle is phi 2. Okay, all right. So we are so the angle, extreme angle is phi 1, extreme angle is phi 2. Alright, the maximum angle is phi 1, up is phi 2. Clear? Okay. Then this will be, so integration down minus phi 1. It says it's below, right? Phi 1, and it goes where? To phi 2. Alright. Integration. Then this will be mu 0 I by 4 pi x. Integration of cos theta is sin theta, right? Where the limit it goes from phi 1 to phi 2. Alright. Now upper limit minus lower limit, right? Then what is the magnetic field? Magnetic field is mu 0 I by 4 pi x. What it is? Upper limit. Upper limit is sine phi 2 minus lower limit. What it is? Sine minus phi 1, right? Minus phi 1, minus into minus, what it will be? Plus, right? So ultimately it will be what? 5. Okay, so this is the expression of magnetic field at this point due to a finite wire. Okay, so you need to remember it. Okay, remember it for the time being. Okay, now special case, which you are going to deal again and again in many cases. Okay, what is the magnetic field? What is the magnetic field at P? Magnetic field at P is what? Mu 0 by 4 pi I by x. What it is? It is sine phi 2 plus sine of phi 1. Right? Now, let's take one special case. Okay. If wire is infinitely long, very, very long wire it is, extremely long wire it is. Okay, then can you tell me how much phi 1 is? Can you tell me how much phi 1 is? Very, very long, means this angle, if the wire is made very, very long, then that angle will what? Keep on increasing, right? Previously, theta is smaller, phi 1 is larger. Then if this is long, larger, maximum will be what? 90 degree. Are you following me? Okay, if the wire is very similarly, how much phi 2 will be? Phi 2 will be also 90 degree. Means what? See, again I'm saying, this is a very, very long wire. Okay, then at any point, this is the perpendicular distance. This angle we call it as theta. This is perpendicular distance. This is phi. If the length of the wire here, extreme, what we take, which it is, this is phi 1, right? If you increase this length, another length bigger, what is the maximum? Maximum can be 90 degree only. So if it is so, what is the magnetic field? Magnetic field is mu 0 4 pi I by x. Sine 90, sine 90. How much? Sine 90, 1. Sine 90, 1. 1 plus 1, how much? 2. So this is the magnetic field due to the extremely long wire on the perpendicular distance. And what is the direction of field? The direction of field is inward, right? So direction of field is